So Google Hangouts is saying that I'm live. If anyone is listening, please let me know if you can hear me. Oh. This may be a quiet session then. If
I can hear you.
Okay, that's good.
They're just kidding.
Oh, true. Turn your volume down now. Okay, so I'll wait a minute before getting started. I just wanted to make sure the audio was working so we'd be ready to go right at 4. But I'll wait one moment and then dive into the session on SQL, SQL.
Yep, there you go.
Yeah, so there's should be, I think, 2 more sessions after this one today. So people who are still around, I think you can see, who is it? Who's doing the, Matt Davis is doing software installation issues after this session. And then I think Tracy Teal is going to be available to talk about data carpentry after that.
Did McMahon laugh at your tweetings? Was that you or Trina? It's me.
Okay, so I'll go ahead and get started. There don't seem to be a lot of people viewing right now, but hopefully you can sort of catch up as you join in for others joining later. So in this session, I am going to be teaching through at least the first part of the software carpentry intro to SQL lesson. And I have 2 main motivations for doing this as a session. When the instructor retreat was originally brought up, or the idea was created, one of the reasons people were interested in having a retreat is sort of just learning new skills and new programming languages. So one reason that I'm doing the session on SQL is to teach the lesson, and people who've never seen SQL before can have an introduction, sort of a basic live demo, and see what it's all about. But my sort of second goal in teaching this session is to, if you already know something about SQL, or even if you don't, and you're curious as to how it would look like if you taught it, this is an example of what teaching the software carpentry SQL lesson looks like, how it might flow, what you might actually say, how the commands look when you run them on a real computer, and that kind of thing. So I will add the caveat right now that I myself am not an expert SQL user. I don't use it on a daily basis. I don't know much about it. Most of what I know is actually from preparing for this lesson, and I've never taught it either. So the third goal of this session is kind of to demonstrate what it looks like for someone to teach a topic that they may not have a strong background in and may have never taught before. And so I'm hoping to teach for about 45 minutes and get through probably the first half of the lesson material that's online, and then spend the last 15 minutes of the session talking about how I prepared as a first-time instructor. And if people have questions about that or want to share sort of their own experiences, then that'll be welcome as well. So to sort of set the stage, as I said, I'll be using the Software Carpentry SQL lesson. So I will bring that up really quickly so people can see what I'm talking about. Oops. Here we are. So if you'd like to follow along, you certainly can. You'll have to get set up pretty quickly. But the discussion page has the sample database that I'll be using. And I'll be going through hopefully the first several topics, mostly in that order, although I may do a few things slightly differently than what's on the website. Feel free to take notes in the Etherpad for this section, and I will be pausing for questions occasionally, and you can throw those into the chat window of the Etherpad at any time. And there's some people in the room with me, so they can also kind of get my attention if I have any questions I need to answer. So I'm going to get started, but before we dive into SQL itself, I'm going to give a little, I guess, background or context for what we'll be doing. SQL is a tool to deal with tabular data. So data that is in tables, rectangular forms, rows and columns, sometimes called fields and records. And there are lots of other tools for handling tabular data like this. So most people have probably used Excel at some point or another. There's the programming language R has a lot of functionality for dealing with tabular data. The Pandas module in Python. And so SQL, in some ways, is just another tool to deal with data that looks like this and perform some basic tasks. So all of the technologies I just mentioned are able to do some basic functions when it comes to data that looks like this. That's in this table form. Is that you often want to be able to select values based on some type of value to maybe filter out the pieces you want. So for example, I might want all of the names of people who took this particular type of reading in this spreadsheet. And maybe that'll give me repeats, so I only want a distinct list of names. So that's one set of operations I could perform on this data. Another is maybe I want to choose the data that's in this column. Again, only the rows that have the salinity, the quantitative measurement column. And then I want to calculate something, like an average. And so when you have data like this, no matter what program you're using, often you're trying to either select pieces of the data by rows, columns, distinctness. And then after that selection, you're often trying to perform some calculation. So if you can think, if you've used other programs like Excel, R, or Python to do this, it might be helpful to realize that what you're doing in those tools is very much the same as what you'll be doing in SQL, just the syntax will be different because it will be SQL syntax instead of, say, Python or R. So we'll see this particular table in just a little bit when we get farther into the SQL lesson. But for now, I'm going to actually open up my terminal. So I'll be interacting with SQL through the command line, but there's lots of other sort of plugins and ways to do SQL queries and use it to manage data. And so the basic idea of writing queries will be the same across those. So it's just going to look a little different depending what tool you're using. So I'm going to open SQL, SQLite, and I have to figure out where I put the database. There we go. So I'm going to open up my database in a SQL program. So let me pause there momentarily. I'm going to have the Etherpad open on the side. And if anyone has any questions or is having trouble hearing, go ahead and make a note in the Etherpad or add that into the chat. Okay, so I've opened this database in SQLite 3. And so it's essentially I've done what I had done in Excel, where I opened a spreadsheet in Excel. Oops. I've now opened a database, which is essentially a set of tables in this program. And if I do dot tables, I can see the different tables I have. I'm going to run 2 commands that will change the formatting of my results just to make them a little easier to read. So now the first group of ideas I want to talk about is how to select data from the tables that I have. And so the first thing I'm going to want to do is select columns. So if I type select star, star is the wildcard character. So in this case, that's going to mean select all the columns. And then I just choose which table I want to use. And so that gives me the contents of that table and the column headers at the top. And so to choose particular columns, I just need to type what they are. So I'm selecting personal name and family name from the person table. And then I get just those 2 columns without the third identity column. So it's worth noting that you can choose the order. So if I wanted to do an order that's used more commonly around the world of family name than first name, I can do that. And SQL is pulling this column, printing it, and then this column, and printing it from the person database. So you can even then do things like this. If I type select ident from person, it'll just print that column 3 times. Okay, so that's one part of our data selection process. We can select types of data from columns. I'll make one more note before we move on to selecting specific rows, and that is I've been using there we go, a format where I'm capitalizing these sort of SQL keywords and not capitalizing the other labels that I'm using from the tables. But that doesn't matter. SQL is case insensitive, so I could do all lowercase, all uppercase. It doesn't matter. It'll still give me the same results. So I'm going to continue using the convention of capitalizing SQL keywords just to make it a little more clear which is which when I'm doing something that's kind of using a special SQL command and when I'm using information from the table. But that is partially a preference thing. Okay, so I've already achieved one part of my goal of being able to select whatever data I want from a table. So the next thing I want to do is be able to select rows. And so to model this, we're going to move over to the, let's double check which tables we have. We're going to move over to the survey table. Oops. So I want to select all the columns from survey just to see what I have. And this is a bit larger table. This is what I had in my spreadsheet before in Excel. And so if I want to select specific rows from this table, I can do select all the columns. And then to select rows, I'm going to add this condition at the end of the query called where. And so if I want all of the measurements that were salinity measurements in this lake survey, I can type where quant equals sal for salinity. And I get all of the rows or records that match that characteristic. And so if I want to determine, I don't care where those were taken or who took them, and I just want the measurements, I could select quant and reading. So now I'm selecting those two columns, and then I just get those two columns, but they've been filtered by rows. So putting together select and where, I can choose whichever columns and rows I want from my data based on some criteria. So let's suppose I did want to know who had, which sites had these measurements taken. And I did select taken from survey where quant equals sal. And you might look at this and be like, well, wait a minute. We're only selecting the taken column, which is the one on the left here with the numbers, from the survey table. So how is it going to be able to evaluate this condition at the end? And the answer is the order you see is not the order that SQL uses to think about this query. So SQL is first going to say which table from survey. Then it's going to do the filtering. So it's going to find the rows where this condition is satisfied. And then it will select the columns of the rows that remain. So this should work, no problem. And I just get a list of the sites that correspond with the salinity readings. So I'm not going to go into detail. There's more in the lesson, but there are lots and lots of fancy ways to filter out your rows. So for example, if I go back to my original here, I'm selecting all the columns from survey where the readings are the salinity reading, and I know that salinity readings usually be below 1. So let me double check reading. So I'm going to see if we have any readings that look really suspicious. And in fact, we have 2. So filtering out these particular rows and columns of data, I can see that either the person doing the readings or the instrument they were using had some sort of error because this is way too high for what they should be, or something really bad is happening in that particular location. So there I used the and operator, so you can build queries where you have 2 different criteria. So something like select star from survey where person equals lake or person equals row. So this will give us the readings done by these 2 particular people. You can select rows or pieces of data that are like a certain pattern. So there's lots of ways to sort of filter which pieces of data you're getting to return based on specific criteria. Okay. So I will pause and ask for questions. There may be a time lag, so I'll move forward a little bit. But if you have questions, definitely ask them now, and I'll try to get to them after I've gone through the next topic. Okay. So the final piece of basically extracting the data you want. So we've now extracted columns of data and rows of data based on certain conditions, is to take that data we've extracted and do some sort of basic manipulation like sorting and figuring out which items we've selected are distinct. So we'll do distinct first. So still in the same table. So I'll print that out one more time so we all know what the original looks like. Make this a little bigger. If I want a list of all the people who had taken measurements, I can do select person from and if I throw in distinct before person, it should give me a list of all the distinct names. So that just filters the output in that column and removes duplicates. Note that, so if I did something like select distinct taken quant, so that's this first column and this middle column from survey, but this will print out distinct pairs, not necessarily distinct of one or the other. Because it's not clear which is which, it'll print out distinct pairs. Whereas up here, because there was only one thing, it'll just give me a distinct list of those. Okay, so that's just an extra keyword you can add to get that sort of data selection that you want. And so the other thing I mentioned was being able to sort data. And so I could select all the columns, again, from survey. And just like before where we added the filter at the end, the where, I'm going to add a different command here called order by. And then I just list the columns that I want things to be ordered by. So if I want to see it grouped by person, who did what, I could do that. Notice that our empty data slots have moved to the top there. And I can also change the order of sorting by adding the descending keyword to the end. So this is hard to see because the table takes up a lot of space. But once you've selected the pieces of data you need, you can order them just by adding this order by keyword at the end of the query. And you can also combine order by queries. So you can do select, say star, from survey, order by taken. So that's first order by the sort of site name in ascending order, and then by the person who took the measurements in descending order. Whoop. I'm missing part of my command there. Oh, I spelled that correctly. Okay, I'm not sure why that command didn't work. So that's something for me to debug and come back to later. Okay, so that's the main, oh, I needed a comma, actually. There we go. Which makes sense because when we select multiple columns, we separate them with commas. And so if we're doing multiple order by queries, we would expect those to be separated by commas as well. Okay, so between those two pieces, we've essentially now learned how to, given a table of data, select the pieces we need. And so I'm going to do a short interlude about missing data. And then we'll move into the second piece of functionality that these programs include, and that's being able to calculate things based on the data that you've extracted from these tables. And so to answer Daniel's comment in the Etherpad about my previous error, as I mentioned before, but you might not have seen, capitalization doesn't matter in SQL. So I could have done everything capitalized, everything non-capitalized, and I should still get the same result. So I'm going to briefly discuss null values after Sarah's question. She's in the room with me.
Remember the names of like columns or files or the capitalization?
Yeah, so the capitalization thing, I believe once you're inside SQL, it doesn't matter. And so everything is the same. When I loaded the database, because I was in my Unix shell, then it mattered. But once I'm inside, I believe I can use, I think the example they give is something like, you could do something ludicrous like this, which I hate typing so much. Okay. But I will do it all for you as an example. That too will work, although why you would want to do that to yourself, I don't know. Okay, so we're going to do an exciting 2 minutes on null values before we dive into actually doing calculations with values that you've pulled from your table. And so, as people may have noted, if you look at our full survey table, you can see that there's some missing values here where the person who took the readings wasn't recorded. If I look at my visited table, visited, I'll see that it also has a missing date. And so I'm going to do the rest of this example with the visited table. So if I try to select all of the rows in my visited table that were collected before 1930. Guess the syntax error. Got to indicate which table I'm pulling from. It gives me 2. And if I change that to a greater than, see which ones are after, it gives me the 5 that are after, which means that if I run these 2 queries, I'm not going to get all the data in the table because this row with the empty null value for date is not going to enter. So when SQL looks at that null value, the blank space, that literally means I don't know what's here. And so if it asks, is that value less than 1930? It says, well, I don't know, which then becomes false. Is it greater? Again, I don't know. So it's not going to show up in either of these queries. To check for rows with null values, you can use a special query after where, which is null. So if I use that, then I can extract the row that has null data in date, but my other normal queries won't pull that null into my records. And there may be some times where I want all of them, no matter what. And there may be times where I don't want the row, where I don't have the data. So that's just something to be aware of when you're doing your analysis is, do you want to include null values? Do you not? Why? And then choosing the appropriate solution that'll make sure you get the data you need. So another quick example before we move on to calculations, going back to our favorite survey table. If we wanted to select, again, all of the readings that were done by our scientists who aren't named Lake, all the salinity readings, we would assume we can write the query this way. But maybe we also want to know for the readings for which there isn't anybody listed, because it's likely that it wasn't that person. So if we want to be fully accurate here and get the empty reading along with all the other ones that don't match this condition that I added, I need to add a field that like this above captures the null values and prints them out anyway. Okay, so enough on null values. Spend a lot of time talking about nothing. Next up, now that we know how to select data and we know a little bit about the perils of null values and how to get around them, we're going to actually do some calculations. So the easiest way to do calculations is adding them to your select statement. So if I want to increase the radiation readings by 5%, I can just multiply those two values together. So this is again in my survey table where font is red. And that will do that calculation for me on the fly. So to see the most a fairly complex example of this, I can use the round function and then have an expression that basically converts Fahrenheit to Celsius. And it will give me the values that I want. Is that correct? Yes. Okay. So that's the first and I guess most easy way to perform computations on the data you've selected. If you just need to do it on a row by row or record by record basis, you can just add the computation into your select statement, and SQL will sort of do it on the fly for you. However, often we want to perform computations that somehow aggregate the data that we've selected. So we don't want to just multiply everything by 1.05 or convert it to Celsius. We actually want to find out some sort of aggregate or statistical information from what we have. And so I'm going to, we've sort of already seen how this is done. In the previous example, I was actually applying a function called round to the data here that was applied on sort of a piece-by-piece basis so that each of these was rounded separately. However, I could use a different function, one that's going to aggregate the data, in order to get some sort of aggregated statistic. So all of your classic intro to statistics function should be here. So we can find the min, the max, which as we observed before is suspiciously large. So if we were doing a really thorough analysis, we'd want to probably exclude those values. Average, we might want to use, I should use a shortcut there. Let's round that average to 2 places. There we go. So these behave sort of as you would think. So it's, if you know something about using functions in a programming language, it's the same idea here. And what happens when you apply the function to the columns you're selecting depends on what that function does. So these particular functions will take all the values and provide some sort of summary aggregate. And so I could do, and you can do more than one. So I could do the minimum reading, the maximum reading from survey. Whoop. And then if I wanted to filter out, I had where font equals this is the salinity readings. And if I wanted to exclude those suspiciously large ones, I could add reading is less than 1. Oops. To finally get a piece of analysis that I think is accurate. Okay. So again, if people have sort of questions about the material I'm going through, feel free to throw them into the chat. And I'll try to get to them after I do the next topic, because there's a little bit of a time lag, so it's sometimes hard to answer questions in real time. Yeah, so the last piece of doing computations with data you've selected that I'll talk about is we've now talked about how to apply some sort of computation on a piece-by-piece basis. So at the very top here, this was applied to every piece of data in the reading column that I had selected. We've done some aggregation where it takes all of the data and produces one number. But it's also possible to group your data into pieces and have the aggregate function act on the pieces individually. So I need to find this in my notes. So I think the example that's given in the lesson is, what if you wanted to find the number of readings that each person had created? So let me throw this table up again so we know what we're talking about. The number of readings each person had done and what their average was. And we'll focus on these radiation readings. So we can't do this all at once because it'll lump everything together. And we don't want to have to do it individually for each person. That doesn't make a lot of sense either. So what we're going to do instead is use one final keyword. So in the end, we want the person's name. We want the number of readings they took. And we want the average. So these are the sort of modifications we want to do on a person-by-person basis. Is we want to know the person's name and the number of readings they took and the average. So we're taking this from the survey table. And we want to filter the rows so that we're only looking at a certain type of reading at once. So now so these two lines are selecting essentially the rows and columns we want and indicating what kind of calculations we want to perform. And this final statement, not order by, that's going to sort them, is called a group by. And that means do all of these things, but do it in groups based on the values in this person column. So then we get a list of the people, how many readings they took of this particular type, and what the average is. And we see that this person's is a lot higher than everybody else's, so maybe there's a problem there. So that's kind of a complex example, but it's putting together all these pieces. So there's really not so many SQL commands. We've got select, from, where, we had distinct and order by, and we now have group by. And when you put these all together, you can do some fairly complex things. And what you want to do is build your analysis up in pieces. So I might start with, I want to find the people in this table who did these readings. Whoops. Let's start there. Well, and actually, I want the readings too. So, and then I start to think, well, I want to group by the person. And so when I do that, I don't just want the reading, I want some sort of aggregate, so I'm going to do the average, the long query. And then you just build up your queries that way until you can do the piece of analysis that you wanted to do. So I'm still not seeing any comments in the chat, so I'm just going to assume that everybody is following along beautifully, and you're all going to go away and write fabulous SQL queries and wow your collaborators. Okay, so I am almost at the point, I think, where I want to stop doing this sort of live demo introduction. So there's more to this SQL lesson. I've actually not included probably one of the most important pieces, which is data hygiene and how you actually should store data in tables like this. So I think if I was teaching this in a workshop, that's something I would definitely include. I would want to have a discussion of, you know, if you look at all the tables, remember your keywords. And so on. Why did they choose to make these tables these ways? How is the data organized in a way that makes it easy to find what you want? And the other main topic that's left in this lesson is joins, which I'm not going to cover in any specific detail. I'm just going to basically type it up so you can see what it looks like, but then people, they really want to understand, will have to go and read the lesson themselves. But basically, this is selecting data part 2, selecting data black belt. Maybe you need information from 2 separate tables. You don't just need data from, say, the survey table. You want to link together the site table and the dates visited table in this particular example. And so the way to do that is what's called a join. And so if you just use the join command, I am missing the from, thank you. It does what is basically a cross product. So it takes every record or row in this table and pairs it with the first row of this table, and then it takes every row from this table and pairs it with the second row. And so you end with all combinations of all rows in the 2 tables, which is not necessarily particularly meaningful, which is why you typically join on a value, where you find the values that will be the same in both tables. And so to do a join, each of the tables must share some sort of value. And so looking at this, it makes sense to match on this column and this column. So we're actually most interested in rows where these 2 values match, because that indicates they contain data that's relevant to each other. So if you're looking at the visited table, you're going to get the right latitude and longitude. So that's the name column of the site table should be equal to the site column of the visited table. No. Name visited. Accurate? Yes. Whew. Okay. And so then we get the rows that we want and the combined tables that we want from our database. And then, of course, maybe we don't want all those columns. So we could do site name, site lat, site long, and dated. And that gives us the location and the date that it was visited. Okay, so that's where I'm going to stop my live coding demo of the lesson. So hopefully that's fulfilled sort of my first 2 purposes in offering this session. If you are following along to learn SQL, hopefully you have a little bit better understanding of what's going on and how it works, and are encouraged to go out and try this example yourself. Like I said, I'm using the Software Carpentry SQL lesson. So if you just go to the lessons page, it's all here, as well as the sample data. So hopefully, if you were here to learn, this has been a good introduction. And if you're interested in seeing how SQL could be taught, this has been helpful in terms of seeing what it looks like to type out the commands and what they look like and what you might say. So my third purpose, which I said in the beginning, was to demonstrate what it looks like for someone who actually doesn't know much about the topic they're teaching to teach something that they've never taught before, because I've never actually taught this lesson. I've only seen it taught once, and most of what I know of the content is actually from reviewing the lesson ahead of time. So in this last 15 minutes, I was going to talk a little bit about that process, how I prepared to teach. So I'll pause and ask if there's any other, I guess, demo-related questions about SQL or about sort of the teaching aspect of things. Definitely throw those into the chat window, and I'll try to pick them up sort of as I keep going. So in my preparation for this lesson, one of the things I did, and which I normally do when I am teaching something new. Oh yeah, I should switch back. Oh, it's in the different window. Yeah, okay, I'm back. One of the things I do when I'm preparing to teach anything is I try to group topics in my mind so that I know just about how long things will take, and I like to give sort of big picture statements up front. It's like, in this main section of the lesson, this is what we'll be learning about, and so on. And so in my mind, I went through the lesson and was like, what is happening here? What are the topic sentences of this lesson in some sense? What are the main points I want to get across? And when should I say them and how? And so when I was looking at the material, for me, it broke down into how to select data, how to extract it, and then how to perform computations on it. And so that's how I was thinking about it. And if I was teaching this over a whole afternoon, I think the first half of the afternoon would be sort of selecting and extracting data, and the second half would be more doing computations and so on. So Daniel, I see your question, and I'll sort of get to it by the end. And thinking about mentally grouping topics also helps me think about where I should pause, where I should ask for questions. And I like to write in, so I like to write in where I'm going to ask for questions, because that's a good way to keep myself from rushing. And if I'm uncertain about what I'm doing, it's a good way to give myself a break and regroup and figure out what I'm going to do next. So that was sort of me just reading through the lesson and thinking about it. And I did a little bit of rearranging based on that. I did the finding distinct values and sorting after filtering by rows, because in my mind, first you select by columns, then you select by rows, then you order and find distinct values. And those are all part of the big idea of extracting data. And then the second thing I did to prepare is going through the commands, troubleshooting, realizing I needed to set the option to turn the column headers on so it would be clear what they were. And when I was going through the commands in the lesson, it switched between tables a lot more often than I was comfortable with. So in places where it would go to a different table, if you noticed, I used the survey table most of the time. Sometimes it would switch to the table with a list of people or a list of sites for just 2 queries. And so some of those I rewrote to use the survey table so that I wouldn't be constantly switching back and forth. And then the final thing I thought about when preparing, the first time I saw SQL taught was a couple years ago, and I don't remember much of it. And looking at it this time, in the intervening years, I've done more work with dealing with tabular data, which was something I wasn't really familiar with the first time I saw SQL. And so I knew part of what helped me understand SQL better in order to teach this lesson was tying it back to things I had learned in the meantime about dealing with tabular data in R and Python. So that helped me learn. And if you're preparing a lesson in something you're unfamiliar with, if you can find points of contact with things you already know, I think that's really valuable. And that's also something valuable to say to your learners. If they are coming from a similar background as you, if you can help them make that connection that you made to help you learn the material, that can be really valuable, especially if you point out that this is how you learned, is that making this connection was one way for you to learn the material, and it might be helpful for them. It might not be, but it doesn't hurt to say for people for whom that might be a useful connection. So yeah, so Daniel, to finally answer your question, is there a command to convert CSV files into SQLite 3 database files? So at the end of this lesson, on the Software Carpentry website, there's, let me see if I can find it real quick. The 10th topic is programming with databases, and it talks about using the SQLite 3 module for Python in a Python script to basically parse a CSV and do things. So I think it mostly talks about getting information, but I'm pretty sure you can also use it to create a database, and I'm almost 100% sure that there's a command that will convert CSV files into SQLite 3 database files. All SQL database programs have slightly different database file formats, but most of them you can extract CSVs from the database. So going from one to the other should not be too challenging. So yeah, that's not something I know, but Google is the answer in this case, I think.
I found it.
So my helper in the room has found a potential solution. So that's all I really had planned. So there's about 5 minutes left. I'm willing to hang around for another minute or two. If anyone else has any questions they'd like to throw into the Etherpad about teaching this lesson in particular, or teaching unfamiliar topics in general, or that kind of thing. And otherwise, for all of you who are watching, thank you. I hope it was useful and helpful to you. And have a good whatever time of day where you are, because I know there are people possibly in many time zones listening to this. So I'll hang around for another minute or two for questions, if anyone has any. Okay, so I had a question pop up in the Etherpad. How much time did I spend studying the material versus preparing, or were these combined? For me, they were pretty much, it was most preparing the lesson. I basically learned what was happening as I went along to prepare, which is part of the reason I think if I was teaching this for 3 hours, I would have done a full read through first just for learning without thinking about how I was going to teach it. So I would be better prepared to answer specific questions that might come up about SQL itself. But yeah, most of it was a brief read through so I could conceptually chunk the ideas, and then starting to go through the actual queries and seeing how the flow of those worked, and changing them if I thought they needed to be changed, and figuring out which ones I wanted to omit because I thought they were less important, and that kind of thing. And so overall, I probably spent, I can't, trying to think of how much time. Couple hours? Certainly less than 3 hours. Putting all of this together. So, and that was being fairly unfamiliar with the material. So
That was 2 hours going through it and also preparing for the lesson?
no, 2 hours total. Yeah, 2 hours to 2 to 3 hours total, I would say. But yeah, that's a good question. Thank you. Like maybe like 45 minutes of just reading through, and an hour or so to put all the pieces together. So any final questions? It's been 30 seconds. Okay, so I think that'll be it for me today. I will mention that the Data Carpentry ecology lessons also have a lesson on SQL, and they are using the Firefox SQLite plugin as their interface. So if you're interested in seeing what this would look like, not in sort of the ugly black box command line, I would definitely go check that out and see if you can get it to run. The queries will be built in exactly the same way, but you can see a different, just a different tool to do the same thing. So thanks for everybody who was listening along, and I hope it was useful to you. And again, have a good morning, afternoon, evening.